Welcome to the beginning of week 3. Yeah, week 3. I'd like to say hello to everyone joining today from the live land of watching lectures live. We have less people here today than normal, as would be expected on a public holiday. And for those who are watching later on, hello. Hope you enjoyed your long weekend. Surprised this little chat thing isn't working correctly. Let me try and make sure that's working. Okay, this should work now. So just to a quick point first, as of today, well, by the time you're watching this, your iteration 1 pull request, merge request should be merged into GitLab. So go to your group's GitLab repository and go check out the merge request tab on the left, and there should be a merge request sitting there for you. We're not 100% sure why it didn't merge automatically. For some groups, they just had to manually click merge. If your group has had problems with this, please post on the forum and we can help you out. But essentially, it's honestly as simple as coming, to go to your project and come over here on the merge request part, and you'll see something like this, which you can click on, and then you can merge it in, right? If you can't merge it in for some reason, that might happen to some groups, but again, we'll deal with that case by case. GitLab seems to be doing this thing sometimes where it loads for a long time, but we're out of control, but it seems mostly okay here. So you can literally just go and click merge here and it should merge itself in. I randomly merged someone's lab update in there, but keep an eye on that. If that says 1, there's going to be something that you might want to merge in at some point. Now, getting into things today, today we're going to be talking about a fun topic, which is data interchange, which I know doesn't sound very fun, does it? But it is quite fun, believe it or not. And here we go. Perfect. So, data interchange. Now, what in the world is this topic? So let's first understand why we're here, why we're talking about this strange and interesting topic. We need a common way of communicating between different operating systems, servers, and programming languages, right? You think about how many languages exist out there. C and JavaScript through to, that's programming languages. Then you got operating systems like Windows and Mac. You have different web browsers, Google Chrome, Firefox, Safari, Internet Explorer, Edge, all of these things. And these are all different pieces of software. And we need ways to try and make them be able to talk. So we're going to be talking about standard interfaces generally. We're going to be talking about JSON, YAML, and XML, which are certain data interchange formats, which you'll see a lot in your career most likely. So firstly, what is a standard interface? If I just asked you this point blank and asked you to think about it, I don't know what you'd tell me. But rather than think about definitions, let's just look at some examples. So here's one example, right? Have you seen something like this before? These are a USB Type A cable. You've probably seen a bunch of them. I have one right here, right? There you go. USB Type A cable. What is the point of these cables, these are what you would call a standard interface, because what they do is they say, it doesn't matter again whether you have, a Mac or Windows or something else. We will create a port on most computers that you can plug a thing into. It's a way of connecting different things together. Taking out of the computer space, we have bolts. You probably, if you haven't thought much about this before, most bolts are standardized around the world so that no matter what kind of thing you're building, there's only a certain set of bolts. So it's the same with screwdrivers. If you've ever had a screwdriver, right? Have you noticed that there's usually only a couple of types of screwdrivers? In reality, there are more. But again, all of this is about trying to provide standard ways for things to connect. The internet, which we will talk about in more depth later. And a random example that I throw in at the end, which is train tracks. There are lots of different trains out there. If you live in big cities like Sydney or Melbourne, you'll see different types of trains, some going in the city, some going out of the city, but they all tend to use the same tracks, and the track is like an interface. It's a way of getting multiple things that are different to operate kind of in the same world, and that's really important. It's a really important principle, and that's kind of what we're talking about today. So all of these systems have in common that they are a standard interface, which we're referring to as a universal method of connecting different systems together, if I haven't said that enough times already. Now, when it comes to data or the software world, we actually do have standard ways or standard interfaces of how we transfer and store data between different applications. You know, if you have a C program that outputs some data that you want a JavaScript program to use, how do you communicate that data? Well, one data type you're probably quite familiar with is a CSV, right? A comma-separated, what does the V stand for? Comma-separated values, sorry, of course. You know, so you have like a CSV file or something like this. But these are all different types of what you might call a data interchange format. Now, the definitions of these blur a little bit. Sometimes you have things like CSVs, you know, Excel files, which, or, you know, Google Sheets files, whatever, that may not be designed for interchange, may not be designed for transit. They might just be designed to store something. But a lot of these are designed to transit. When I say transit, I mean, you know, move from one place to another. So, there are many types of these data interchange formats, which are standard interfaces for how we transmit data between different places. And they are really, really simple languages, typically, and they're not even languages, to be honest. They typically are only really capable of storing some very basic structures. And two or three that we're going to look at today really just do arrays, objects, strings, booleans, numbers. That's kind of all they do. And we're going to talk about JSON and YAML and XML today. So, firstly, JSON. JSON is called the JavaScript object notation. Now, before we get too deep into this, let's not get it confused with JavaScript specifically. Just because it has JavaScript in the title, it does not mean that it's somehow like super tied to the language. In fact, you know, I think JSON has about as much to do with JavaScript as, you know, JavaScript has to do with Java, in the sense that you could use JSON, JSON here, with Python or another language, and you wouldn't even need to understand JavaScript or have any context there. So this is the official spec for it, but you're never going to read that. It essentially just describes, it just describes what, it's like a language definition in a way. It kind of describes what it is, how it works. This is something that someone writing a compiler might come and read. It was written by a bunch of smart people, like most of these things. I don't know if we have authors here anywhere, contributors. There we go. Douglas Crockford. Douglas Crockford is a fairly influential person in the world of JavaScript. I would say that a lot of the stuff is probably a little less relevant nowadays with some of the boom from the big tech companies, but like 10 years ago was doing a lot of interesting stuff. Was definitely a great source to learn from. But let's get into the language specifically. JSON is a format made up of braces. Some of the language here needs to be updated. It's made up of braces for objects, square brackets for arrays, and then all non-number things that aren't numbers are wrapped in quotations. And it's actually very similar to a JavaScript data structure. You don't need to know JavaScript to use it, but it's very similar to a JavaScript data structure. So this is a piece of JSON, and you'll notice immediately looks nearly identical, right? You see it here, and it's okay, looks quite the same. An object with one key. That key has a value, and that value is an array, and that array is 3 objects, and each object has its suburb and postcode key and respective values. A couple of things that are different with JSON compared to JavaScript, though. Firstly, in JSON, you can't have trailing commas. So remember how when we did the lectures on JavaScript objects and arrays and stuff, we said, oh, put a comma after all of your lines in your objects or arrays, because it makes it easier to remove and add lines. The JSON standard does not include that, so you don't put those commas there. It might break things depending on the JSON encoder decoder you're working with. And object keys must be strings and include apostrophes. So what we mean by that is that in JavaScript, you could put commas here, and you also probably don't actually need, well, you definitely don't need, it's not required to have these apostrophes. So like that's valid JavaScript, just writing the word without the double apostrophes. But in JSON, you kind of need that. In general, in JSON, unless you're dealing with a number, whether it's a key or a string or something else, it needs to be wrapped in a double apostrophe, and not singles either. So there's no single apostrophe notation. It needs to be doubles. Most languages have a capability of processing JSON. In fact, we looked at this back in week 2 when we touched on testing, right? We did this little lecture on testing. And so it should already be familiar to you. Some languages like Python, I don't think have a JSON encoder built into it, but languages like JavaScript do. When I say built in, it's kind of just like, do you need to npm install anything? And in JavaScript, you don't actually need to. So let's have a quick look at an example of this. Let's see if there's one in the slides or whether, yeah. But let's look at a simpler example first. So let's just imagine for a second that I'm going to go and create a file here called fun.javascript. So I'm writing a JavaScript file here, and this file is going to be used to generate some JSON. So I've kind of said, oh, JSON is this thingy-majig here, right? But what is it actually, right? Like, it's not a programming language. Sometimes it's what we call a markup language. One of the differences between a programming language and a markup language is that a markup language kind of can't do programming things, such as loops and if statements a lot of the time. It's often just kind of declarative in nature, which means you just kind of state what things are. But the main advantage of JSON is that it can be turned into a string. It's really that simple. Something like this can be completely compressed down into ASCII characters. Doesn't have to be ASCII, but there's no funky things. You know, like you could kind of imagine it can get quite complicated if you were to try and picture, you know, how would you represent a C struct in text, you know, or ASCII or something? Or how would you represent, you know, a JavaScript array? Because a JavaScript array isn't just the data, but it's also the length, because remember, the length is stored in the array, and a whole bunch of other properties are stored within the array. So JSON is a very simple format, and the idea is that it all gets compressed to this, and then it gets stored in a file, and that file is basically just a string. So it's kind of a way to stringify your data, you know, turn it into a string. Sometimes we refer to this as serialization, which is to take a big chunk of data and kind of output it to a big long string. And that's all we're really trying to do. So if I have a data structure, for instance this, and it's very similar to JavaScript, if I define it as, you know, const my data equals that, and let me get rid of all the double quotes for us, and let me make it slightly more JavaScripty, like this. Right, fairly simple program, doesn't do anything yet. Node fun.js. But if I go console log json.stringify, and we've done this before, and I output my data, it will output a string. It will output that object and series of arrays and data inside of it, collapse it into a string, and output that on the terminal. And as we've shown before, if you just try and console log my data, you will get the same thing, but to JavaScript, you are asking it to print out a data structure to the terminal here, which is why you get the nice formatting and the colors and stuff. Whereas in the second one, JavaScript is not aware that this is a data structure anymore. JavaScript can't distinguish this any more than it can distinguish between me asking it to print this out. Oh my goodness, that's not what I wanted. Let me copy that properly. Oh no, you have to use single quotes. So, you know, for JavaScript, me saying to print the stringified data is no different to this. It just sees it as a string. And this is good because this string can be saved in a file and then used by a C programmer. It can be saved in a file and used by a Java or a Python program. Similarly, I could send this over the internet because the internet's really good at sending strings over over itself, right? And basically, everything is a string on the internet. Got it? So if we, there's our little simple program here. Let's have a look at a bit more of an involved example and actually see ourselves write something to file. And it's also a good chance to stretch our wings and use another library, which is the file system library. Now, if you remember from our NPM lecture, the file system library is not one we have to install because it is a built-in library. There were those JavaScript libraries that were built in to, I can't remember which page it was on. Doesn't really matter. Built-in modules, something, maybe it's here. That's somewhere. You can go back and look at the old lecture. I don't know where the link is off the top of my head, but there we go. Sorry. I think I just found it. Yeah, so file system's one of them, and let's have a look at using that particular library here. So I got this file 3.1 JSON here, and you can see that file is relatively straightforward. I import a file system object from, I guess just like from the built-in like file system library here. It looks a bit weird, import fs from fs. And then I've got my data structure. Now I've just got it in all caps because it's a constant, doesn't really matter. I've got a dictionary of names. So it's the same structure as the last thing, though the kind of content of it's just a little bit different. And then you'll see I'll stringify it down here, and then I'm going to open a file called export.json, and I am going to put all that data, I'm going to send it to write to the file, and then when I open the file, I'm also going to give the file a particular flag whilst I'm opening it. This is a signal to the operating system that essentially says, hey, I'd like to open a file called this. This is what the file's called. I would like to be able to write to the file. That's what the W means, and I would like to write that data to the file. And you'll see that if I go inside my emb1 source folder, and I go node 3.1 JSON it just created a new file for me, export.json, and this is the JSON file right here. It has been outputted to a file. It is just text. And this is why we talk about it as an interface for data transfer or data storage. This is why we talk about it as a data interchange format, because this file is now able to be read by any program that has a JSON library, right? Again, Python, C, Java, whatever, doesn't matter. They can all read this file with their own JSON libraries and import it and structure it back into their own language. Because how an array works in C is very different to how an array works in JavaScript. But through this common interface, we can have them talk to each other. I can also open that file if I want, do the reverse, which is I still import file system. I now read a file, export.json, and when I open the file, because I'm only reading from it, I can tell the computer, because JavaScript has to talk to the computer to get this data. I tell it that I'm only want to read from that file. I don't want to write to it this time, I just want to read from it. And then what I do is I take the raw string, because remember at this point, the JSON variable, as we'll see here, is just a, oh, there you go. It's even less than that. It's basically just raw data coming from a file. In fact, I wonder if I could convert that to a string first. See if it works. Yeah, so this is, without getting into it, this is like kind of, when you read from files and other things away from the from your program, whether it's like a disk or a network, sometimes they become buffer objects. This is not something that you need to know about for the course, but It's essentially like a stream of bytes coming in from that source, again, whether it's the internet or the hard drive. In this case, we just converted it to a string here, which made it easier to print. But this is what we got from the file, and we want to kind of take that JSON string and turn it into meaningful JavaScript objects. So we parse it into a new data variable, and that data variable will have something that resembles an actual JavaScript structure, which is why I can now do something like say, hey, for data.names 0.last, and that should give me car, right? So from that text file, JavaScript's been able to open that, grab that string, decode it, or parse it, as it's called in JavaScript, turn it into a real object, and then use it, which is very, very useful. I think that's it. So that was JSON. Now, the reason we talked about JSON is because it's going to be, it's part of your iteration 2 in a bit more detail, so you don't really need to get super comfortable with it yet, though you do need to get a bit more comfortable with it, maybe in week 5. But we wanted to also introduce it early because whilst it's not like kind of critically used in your project, it's kind of part of package.json, which we talked about last week. So we're just trying to, I guess, give more context to these things, and that's why you can see here that when you actually look at package.json here, this is actually just JSON. Now, you might be asking, okay, well, this is some kind of lecture on data, standard interfaces, and data interchange formats. So what is this package.json? Where is this being transmitted to? Where is this being interchanged with? I didn't think we were sending it anywhere. And you're right, we're not. There are pretty much 2 reasons that you use stuff like JSON or the other, interface interchange formats. One is to send things. The other is just to store basic information without a lot of overhead. Because, if you were to try and store this information in a text file and you just wrote, env1 script as something that does, echo hello, you'd have to teach your language how to interpret it, how to turn that raw text into a meaningful structure. But by using JSON, it's kind of like a really easy way to it's used a lot in configuration files. It's used a lot to kind of write notes and so everyone can interpret it. So here we're not sending this file anywhere, it's just JSON's a really easy way to represent it. So the second data interchange format we're looking at is YAML. YAML is the recursively defined YAML ain't markup language. It's a popular modern interchange format, and it's kind of like the easy to read JSON. That's kind of whereabouts I'd say it came up. And what you see here is actually identical to, if I go back 2 slides, it's actually identical to this. Right, so these are the 2 things in JSON and YAML, and the emphasis with YAML was to get the same information, but to be able to convey it a bit more concisely, so it's a bit easier to read. It can be a bit hard to read immediately, but once you get used to it, it's a bit more concise. Jack has asked, does this mean we're going to be using another language? No, not at all. This is just... Oh, I see your question. So your question is, are we learning JSON because Hayden keeps talking about how we can transmit data between different languages, for instance, and therefore are we going to learn a second language? So no, we're not learning a second language, though the reason we're talking about this is because as we get into iteration 2, you'll be learning about how to kind of transmit data from one JavaScript piece of code to another JavaScript piece of code over the internet, kind of thing. So it's about sending JavaScript to JavaScript over the internet is the short answer. So when it comes to YAML, unlike JavaScript, indentation matters, which is a little bit new. And what that means is that this postcode here, if this was, and if I just copy and paste this into an editor for a second, if this postcode here was like that or like this, they mean very different things. So unlike JSON, indentation really matters. A dash is used to begin a list item, and that also can be a little bit strange at the start, because when you look at something like this, you might think, okay, what is this? But this is saying that a key locations has each dash is a list item, has 3 items in a list, and then each thing between the dashes is essentially an object. So it's kind of like, okay, I've got 3 locations. Each one is some kind of object with 2 keys in it, suburb and postcode. And that's why it kind of looks very similar to this. It essentially just removes braces. It removes braces, and it removes double apostrophes, and it removes square brackets to make things more concise, even though it means the exact same thing. There are a lot of YAML to JSON converters online, so you can kind of play around with this if you'd like to. For instance, you could go to like a random website, I'm sure there's more of them like this, and you could come in and you could say, okay, well, I'm going to make an object, and that object's going to have, movies, okay, and the movies are, what is it, like Doctor Strange and Top Gun, like this, and I'm going to get, okay, and I'm like, okay, that's what the YAML looks like. And then if I make another one like songs, I don't really listen to music these days, but I'm just going to make up some names. Happy Harold and the Goombas. Great. You can start to see how this might be laid out. And if you make another dictionary inside that, such as media, there you go. Like, you can again start to see how that is structured. Yeah, that's really it. You can play around with this as much as you want. Have fun with it. Scarlet width, yeah, right back to that, which is good. That's it. Now, one thing that's important about YAML is that whilst we kind of started this lecture talking about data interchange formats, YAML is probably an example of something that's much more common for configuration files and less for transferring files. Its dislike for indentation makes it a bit harder to serialize, to package up into a string, because you usually don't like markup languages like YAML that are kind of white space sensitive being packaged up into a string. So YAML is actually a really common example of what you might use for like a package.json in your NPM library, but not for something you'd use to transfer data over the internet or something like that. But it's still really, really popular, and it's probably, I'd say it's becoming more popular when it comes to configuration files. And then lastly, we have XML. XML stands for Extensible Markup Language. It's pretty much the original version of this. It was kind of what JSON and XML both were before they really were around a lot. It was very verbose. So to communicate the same information that we've seen in the YAML file or the JSON file, you had to write all this kind of information, which was quite a lot. One of the benefits of XML was you could actually go and put attributes on keys, which was quite a novel thing, which isn't that exciting, but you could essentially say here, postcode state equals New South Wales. You could write it like HTML for some of you who might have been exposed to that. That's about the only feature it really has that JSON and YAML don't, but it's a big who cares, because you could naturally go and structure this by, indenting it by saying, state is New South Wales and code is that, so it's not really like a unique thing. It just is a slightly more concise in that regard. But overall, it's very verbose. It's very old. Parsing it is really expensive because I think it's just a little bit more complicated to interpret. It takes up a lot more space. Like if you look at a file like this, most of the text, most of the ASCII being used to represent the data is not actual data. It's just boilerplate. It's just kind of structure. And yeah, it's just harder to read as well. But you'll see it around a lot. It's still floating around the internet lots and lots and lots. So keep an eye on it so you know exactly what it is. That pretty much brings us to the end of this little lecture on standard interfaces. Again, to recap, we talked about what a standard interface is, the importance of it. We talked predominantly about JSON and YAML and their usages as both kind of simple stores of data, as well as a way to stringify data and send it. And JSON and YAML are both used for the stores of data methods, and JSON is a lot more popular on the transmission, on the data interchange aspect. So yeah, that's pretty much the crux of that. Please leave some feedback over here on the lecture. Click the link if you're on the slides. Take a photo on with the QR code if you're on your phone. Thanks.